Okay, everybody. Sorry, I'm back. I thought I could make it, but I didn't get them all the way through. So we left off with finding the probability of someone that uses credit card frequently. And again, we said, well, there's 2,834 people that say they use the card frequently. Out of these were all the possible number of people that were surveyed, right? Those were all the people surveyed. So we tallied them up, divided them out. There's my percent. And then here it says, how are all of these results affected by the fact that the responses were obtained by those who decided to respond to the survey posted on the internet? What they're getting at is when you hear probability and statistics, remember you always have to be thinking about sampling. Where does your data come from? How was it collected? Did it use good techniques? If they're only getting surveys from people that are answering this question on the internet, I think there's a big chance that it could be skewed or biased. You're only capturing a certain market of people. Maybe they were on the internet to actually buy something in the first place, in which case there's a very high chance they're using a credit card. They can't use cash or anything. Also, you don't know the age base then too of people that are filling out this survey. For younger people, this might be right. This might be a lot of younger people use their credit card frequently. For older people, maybe that's not the case. So this was not a well-sampled, well-collected survey. There could be bias involved. So you could say a lot of those different things here. Okay, let's try number 4. It says, here they give us a sample space. Use this sample space listing the 8 simple events that are possible when a couple has 3 children. You can get boy, 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 girl, and so forth. Okay, those are all the possible ways to do it. Remember, 2 outcomes, boy, girl. You're going to have 3 kids, so that should be 8 possibilities. Assume that boys and girls are equally likely so that the 8 simple events are equally likely. Find the probability that when a couple has 3 children, there are exactly 2 girls. I want the probability of exactly 2 girls. Okay. Well, if you look back at the sample space, those are all the possible ways you can have 3 kids. And if I look for how many of them are 2 girls, so there I could have boy, girl, 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 boy, girl, and girl, girl, boy. Those would be the only ways to have 2 girls. So that would be 3 ways to pull off that success out of 8 possible combinations. 3 8s. Would we consider that unusual or unlikely? No. 3 8s is 37.5%. Well above 5%, so it wouldn't be unusual or unlikely. All right, last one. Identify the sample space for a couple having 4 kids, and then find the probability of getting 3 girls and 1 boy in any order. Okay, this is going to get to be a pain in the butt because I've got 2 outcomes, boy or girl, but now I've got 4 kids, so that's a total of 16 things in my sample space. This is going to be hard to track. So I'm going to do my best. Again, what I recommend you do is I recommend you pick one and exhaust all the possibilities. So I could have 4 kids that are all boys, right? That's the only way to get 4 boys. All right, now that's exhausted. So what about all the ways to get just 3 boys? Let's see, I could have 3 boys up front and then a girl, or a boy and then a girl and a boy. Boy, girl, boy, girl, and then 3 boys. Those would be all the possible ways to get just 3 boys out of here. Okay. Well, the next would be, how can I get 2 boys out of here? Let's see, this is going to be a long list. So I could have, what could I have here? I could have boy, boy, girl, girl. I could have boy, girl, girl. I could have boy, girl, girl, boy. Girl, boy, girl, boy. Girl, boy, boy, girl. And lastly, I could have girl, girl, boy, boy. I think I've got them all. We'll know at the end if they add to 16. That'll give us some idea. But if you're not trying some sort of a systematic way of doing this, you're just going to get lost. It's really hard to get them all, even if you're being systematic about it. Okay, that was all the ways to get exactly 2 boys. So I've got 4 boys, 3 boys, 2 boys. I need how many ways can I get exactly 1 boy? I'm going to continue the list down here. 1 boy, well, that could be a boy. That could be a boy, girl, girl, girl. A girl, boy, girl, girl. A girl, girl, boy, girl. Or a girl, 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 boy. Okay, that's all the possible ways that I can get 1 boy. And then the last thing would be, how do we get 0 boys? Well, that one's going to be not too bad because that's going to be all girls. Okay, so I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, well, I'll go with that. At least I got the right number. Okay, they say what's the probability of getting 3 girls and 1 boy in any order? So probability of 3 girls, 1 boy. Well, I know there's 16 possible outcomes that can happen. How many of them had 3 girls and 1 boy? Let's see. 3 girls, so 3 girls, 1 boy is 1, 2, 3, 4. There's 4 options. That's 1 out of 4. That's 25% chance of getting 3 girls and 1 boy. Not unlikely. Let's add this to it. What about the probability of getting all boys? Right, the probability of all boys. Well, out of 16 possible options, outcomes, there's only 1 of them, or 1 way to get all boys. And so 1 out of 16th, 1 divided by 16 is 6.25%. So low probability, but not unusual. Remember, it's got to be below 5% to be considered unusual or mathematically unlikely to happen. All right, let's keep chugging along. Next page. So here's where we are going to begin some of our probability rules. You know, I'm going to stop this video and just start a new one because this is a good stopping point. So I'll come back.